Generic dictionaries aren't a data structure, but rather a technique that I found very useful for creating dictionary structures which can handle arbitrary types in C. Now, if you haven't watched the previous video I've made about dictionaries in C and how we can implement them, I would highly recommend that you go to the first link in the description and click on that because it will take you to that video. Since all the code I'm showing you in a minute is coming from that tutorial, and this new feature of generic dictionaries is just building upon that. In the last video, I showed you guys this snippet of code. So we have a dictstruct and a dictAdd function. So the dictstruct takes keys and values and stores them as arrays of strings. And the dictAdd allows you to add a string key value pair if there's space in the dictionary. Now, the current limitation of this approach is that we can only store keys and values as strings. What happened if, per se, we wanted to store the values as integers instead? We would have to change the code so that we have a struct for strings. So we have dictstruct where the values are strings, and we have this another struct called dictInt where the values are stored as integers. In addition to this, we would have to modify the dictAdd function and create two versions of it. One called dictStringAdd and one called dictIntAdd. DictStringAdd will handle cases where we want to insert the values as strings, and dictIntAdd will be used when we want to add values as integers, and we have to pass in the respective structs for each one. Now, the problem with this approach is that it's verbose, since we have to create duplicate structs and functions for each type of value we want to have. So if I wanted to have, let's say, a dictionary for integers, floats, doubles, and maybe a custom structure that have, for example, a two-dimensional vector, then I would have to create new structures for all of them and have to just change the name and change the type of the values array. And then I would also have to create new versions of each of the functions for adding elements, or rather key value pairs, into the dictionaries. And this is just very verbose and it creates a lot of duplicate and messy code. And if you actually notice, we're not changing much in the structures of functions, we're just changing the types. Inside of C++, there's a very neat way to solve this issue, that's through templates. However, we don't have very sophisticated metaprogramming in C by default, so we have to find ways around this. Now, there's two problems you have to solve if you want to create a single dict structure which can handle arbitrary types. These problems are, well, the first one is having a place to store the memory to hold the values, and the second problem is knowing what type the dictionary holds. So here you can see I've added a union called dictValueTypes. Now, a union is a bit different from a structure, or rather a struct. With a union, it allocates memory for the largest type inside of it. So here the largest type will be a char pointer, or rather these all will be the same size because a pointer is always 8 bytes, at least on 64-bit systems. And we can store different types there in the union in the same memory address, but we can only hold one value at a time. So if let's say I allocated a dict values type and then I made it have a string value, then it can only hold strings, an array of strings in that instance. It can't hold doubles. And this is very useful because it allows us to have multiple types and have one place to store them, or we can just store them in a single piece of memory. So by adding this dict value types, or rather creating this dict value types union and adding it as a member in the dict struct, we solve the first problem of having some memory to store the values. The second problem is knowing what type the dictionary should hold, or rather the type of value. So here I have a enum called dictType, and as you can see it holds different values. So we have dictString, dictInt, dictFloat, dictDouble, and dictUnknown. Now string, int, float, and double are just types. DictUnknown is a special member, and it's going to be used in a specific case. So for now we can just ignore it, but you should know that it's useful. So we pass we hold a type, a dict type member in the dict struct, and now we have a way to know what type the dictionary should hold or what type the value should be, and also have memory to store the values. Now the next problem we have to tackle is the dictAdd function, because although we have modified the dict struct so we can hold arbitrary types in a single struct, it won't work with our current dictAdd function, because as you can see, it expects a string value. Now how can we tackle this problem so we can handle different types? I mentioned unions before, and here we can create a dict value union where we can store a single string, integer, double, or a float. And since these will all occupy the same piece of memory, we can just have one type which is stored in them. So by passing this dict value struct as a parameter to the dictAdd function, we know that we can handle multiple types in a single function. And then based upon the type the dictionary holds, we can check if the value is valid. Or rather, we can check what value the union holds. Now there's one last piece to the puzzle, and that's getting values from the dictionary, which are associated with a key. So currently we are returning a string from the dictGetValueAtKey function. However, if you have multiple types, we need to modify this so they can handle different types. So we can employ a similar thing that we did before. I'm going to create a new struct called dictValueResponse, and the dictGetValueAtKey function will return a dictValueResponse. dictValueResponse will hold a value and a type, so the user knows what type the union is holding. And now I will show you guys how we can implement this, and it should hopefully clear up any confusions you may have so far. So here I'm at the code we finished with in the last tutorial about how to implement dictionaries in C. And the first thing I want to do is create a few structs and unions to define some of the things which we'll be passing around in the dict functions. So first off, I want to have an enum called dictTypes, right? And this will just hold the different types of values we can have inside of a dictionary. So we can have dictString, dictFloat, dictDouble, and we also have dictInteger. Finally, I'll add a dictUnknown member. This will be useful when we have in the dictGetValueAtKey function. So if no key exists inside of the dictionary, we can just return a dictUnknown as the type, and the user knows that the key was not valid. So we're going to pass in this type into the dict structure. We also need to have a way to hold the values. So we're going to create a union called dict value types that can hold an array of strings, an array of integers, an array of doubles, an array of floats as well. And if you have custom types, let's say I've got a struct called vec2, and this is just a two-dimensional vector, so we have x and a y, then I can easily add this to dict value types as well. So I can say an array of vec2 structs, let's say vec2s, and then I just pass in this to be another type. So you can modify this code to suit your own code if you have custom structures you also want to add into a dictionary, or you want the dictionary to support. We would also create another union called dictValue, and this will just hold a single value. So a single string, integer, double, or float. Here we're holding, reserving memory for arrays. Here we're just going to hold a single type. I'm going to create one final struct called dictValueResponse. And if you remember in the PowerPoint presentation, I mentioned that dictValueResponse will hold a dictValue and it will also hold a type. And we just returned this dictValueResponse struct from the getValueAtKey function. So when we try to get a value associated with a key. Now that we've got all the structures set up, I'm going to start modifying the code. So currently we have the dictInitialize function, and this just initializes the dictionary with certain values. So as you can see right now, we're allocating memory for the keys and the values. We're setting the size attribute with the one the user provided, and then we allocate memory for the keys and the values themselves, so each individual string. This is fine right now when we're just handling strings, but when we want to support multiple types, we need to pass in an extra parameter called type, and this just tells us what type the values should be. And because of this, we have to modify the code right here. So we have to dereference the pointer, then assign the value. So we're gonna also set the type attribute here. So keys can stay as strings because right now we're just supporting the values being multiple types. The keys are always strings. Although you can modify that if you want using this technique. So with the values, we have to, because values right now is a union. So if you want to allocate memory for the specific value the union has, or rather the type the union is currently set to, we need to have a way to check what type the dictionary holds. And we can do that with a switch case statement. So we can just switch on the dictionary's type, which we just set right here. And then we can just check what the type is set to. So if it's a string, then I'll just copy this and modify it. So in case it's a string, we just allocate memory as we did before for the string, a child pointer, right? I also need to modify this so we are getting the specific union member, which is being currently used. And then I'll just paste this a few times. If you're doing integers, we can just allocate memory for ints, right? Double is going to be double. Float is going to be float. Okay, so this is how it is currently. Now in this for loop, we are allocating memory for individual strings for the keys and values. Now, it's fine to always allocate the individual strings for the keys because the keys are always strings. However, the values, we only want to allocate memory for them if we are holding the values as strings. So we're just going to check if the type the dictionary is holding is a string, and if it is a string, we just allocate memory for it, the individual string. So this is something which might confuse you guys, and I didn't really explain this well in the last tutorial. So here, it may be counterintuitive. I'm allocating memory for strings here, and then I'm allocating memory for it here again. Forgot to add the union member. So why is that happening? It looks like I'm allocating memory for it twice. Well, in this line here, I'm allocating memory for char pointers and then its times size. So strings right now is a pointer, as you can see, is a pointer to an array of or rather, strings is a pointer to pointers, which are pointing to strings. Another way to think about that is strings is an array, and inside the array are pointers to other buffers which contain strings, or the data for the string, so the actual characters. So here, in this line, I'm just allocating memory for those pointers to the strings, or the pointers to the buffers holding the string. And then in this line here, I'm allocating memory for the actual buffer which holds the contents of the string, so all the characters with a null terminator at the end. And this is a key distinction you have to make in C, is that a char pointer just simply tells you this is a location of where the string is. You also need to make sure that the string itself has a buffer so you can actually write data to it. The next thing I want to change is the dictAdd function. So since the value can be multiple types, we just put in a dict value right here. And then if the key does not exist, I just return false, so this code is fine. If you do find a key, you have to modify this code. So we can run strcpy to just copy the contents of the key into the key in the dictionary. And then we will run this piece of code if the struct member, or rather the dictionary is holding strings. However, if it's not holding strings, you have to change the code. So I'll run another switch case statement. I'll just copy this code again. So we just check the type. So here, I could put an equal sign, then we can just modify the code. So here we have an strcpy into, if it's strings that we're holding, we just run strcpy, then we copy at the index here, the value. And the value, we also have to get the union member it currently is. If we're storing integers, then we just get the integer we're currently at. Before I do that, I'm just gonna copy this. So we just assign that to be equal to the value. Then we do the same for the double. And the same for the float. Right. Then we also increment the dictionary's occupied counter to show that we added a key value pair, right? And this looks good for now. Dict get value at key. Before I do these last two functions, I just want to check that the dict initialize and the dict add functions work properly. So I'm just going to comment that. Just see if this works. So dict initialize, we have to add in the last type, which is the data type we are holding, or rather the type the values should be. So here I'm just going to set that to be, let's say, integers. And then in the dict add function, instead of passing the string here, we have to pass in a dict value struct. So just create a dict value, and then I'll just pass in an integer is equal to, let's say, 10 for now. Right. Then I'll just modify these to see what we get. And we got some errors. Let's see what's happening. I think I might have made a typing mistake. Yeah, that's big val. That's an interesting bug. So when we have errors like these, we have multiple errors. Sometimes it's kind of hard to see right now, but let's run build. Go to the top again. Usually it's just the first few errors causing the problem. Okay, so I made a typo here, right? I made a typo. So dict type. This should be dict types. Also here. Let's go through all of them to see if they're typed properly. Yeah, there we go. Okay, we're still getting errors. Let's run that. Let's build it. Let's compile it again. Member reference base type child pointer is not a structure or union. Okay. I forgot to change the type of the values. That's the issue. There we go. Let's run it. Success. Okay. So it looks like we are adding the values fine, and we can also initialize the dictionary fine with the type of the values. So now dict get value at key. How do you fix this function? So currently it only supports returning strings. We don't want that. We want it to support returning multiple types. So we're going to return a dict value response. So if we find the key in the dictionary, instead of just returning the value like that, we have to run a switch case statement once again. So I'm just going to copy the code again because we're just going to be modifying what happens if we hit a specific case. Okay, so we get the dictionaries type, and instead of doing this, what we'll do is, let's just delete the rest first. I'm just going to do that. Okay, so I'm going to replace dictAdd occupied with I first. Then we just have to return a dict value response struct. So I'll just return dict value response, then this will be the value, and the type will just be dictAdd type. We don't have to return this because the user should know. The user can just check the type from the dictionary, but I just think it's nice to return it as well, just so the user knows what the type is of the value. We'll just fill out the rest now, and the last one. Also, we don't need these break statements because if we're returning from the function, we'll just stop executing code there and it'll just go back to the calling function. So we don't need the break statements. So instead of returning null here, we can't return null. So if you remember back at the start of the video, I told you guys, or back when I started writing the code, I added this dict unknown enum member. It's for cases like this where we can't find a key in the dictionary with the one that the user gave us. So since we can't return null, since we have to return a dict value response, I'm just going to return 0 as the value and then dict unknown as the type. So the user knows that the key they provided is invalid and no key value pair exists in the dictionary with that key. So this is also why it's useful to return a type along with the value. Let's hope that this works. So we're just gonna see if this works. So value is it's going to be a integer, right? So we're just gonna do, let's get the value at 3 instead. Also I need to value.integer. We've got some more errors. Okay. Char pointer incompatible, type with double. This is one of the annoying things about Neovim is it doesn't clear the terminal properly whenever you tell it to. Okay, I made a typo there. Integers. No, it's still not happy. Why isn't it happy? Let's compile it first. Initializing char pointer type with expression of type int. Okay. That's a bit weird. Let's see. Oh, okay. So the problem here seems to be. Actually, I'm not sure. Why is it causing that issue? Oh, yeah. This first type is going to be a dict value type, so we have to make this a dict value struct, right? So dict value, then we just add that right there. That should fix it. So these should be dict values, not just the types, just not the value itself. So now if you compile it, we get some more errors. Incompatible. Okay, we have to also specify the type the union is holding. This is going to be a string. This is going to be an integer. This is a double. And this is a float. So yeah, if it compiled, we have these warnings about not handling the unknown, dict unknown, enum. That's fine, we don't have to worry about that. So we get 14 as the value, and that is the correct value. Let's try it again with 4. We should get 16 now, and we got 16. If you try with something invalid, let's say 5, then we just get a value of 0 because 5 is not valid. It's not an actual. There's no key with 5, so there's no value associated there. The last function we have to do is the dict remove key value pair function. So this is quite important. Currently what we're doing is we just if we find a key, we just run some mem moves to be able to move the values around. So the current index of the value, we just copy the element in front of it to the current position, and the rest of the array just moves a single element back. This code is fine because it can work with different types. We just have to specify what union member we are currently using. So most of this code is the code's pretty much fine. We just have to modify a little bit. Forgot to add the switch statement. It won't work without it. Then we just true. Okay, so we can just copy this code right here. We just modify a little bit. If it's a string, we have to specify we're doing strings. We can leave the last one as it is, integers, once again integers. Doubles as well. Then floats. That looks good to me. Let's see if it compiles. Yep, just got a warning about the switch statement, that's fine. So let's try removing the key value pair 4. Then we try retrieving it again. So what I'm doing here is I'm getting the value 4 before it's removed. I then remove the key value pair at 4. And then when I try to retrieve it again, I should get 0 because it should not exist anymore. It compiled, let's run it. Okay, it worked. We get a value of 16 before we remove it. We then remove 4, and then we get a value of 0 when we try to retrieve it again. So let's try that again with, let's say, another element, just to make sure it just works properly. With 2, and it removed 2 as well. This should be 2. Okay, that works fine. Now this is fully functional at this point, but there's another thing that we can do to make this a bit easier to work with. So currently, whenever we want to add a key value pair to the dictionary, we have to manually create a dict value struct as a parameter, or rather as an argument to the function, and then specify the type manually. And you can imagine that if we're making lots of dictionaries, it can be quite difficult to keep track of it. But let's say we have one for integers, we have one for floats. Is this like a different dictionary we're adding it to? Then we have one for doubles. It's kind of a hassle to remember all of it. So we can simplify this so that we just pass in a value directly, and we can use some macros for it to define the type for us. I'll show you guys how we can do that. So first off, I'm going to rename dictAdd into dictAdd implementation. So I say IMPL. I'm renaming this because the macro we're going to be creating is going to be called dictAdd. So I'll go up here. I'll create a macro here called dictAdd. That will take in a dictionary, a key, and a value. And then it will just call dictAdd implementation for us with the same values, with the same arguments. So value right here, if you pass it in as it is right now, it's just going to be a number or a float or a string, or if it's going to be the raw value. That's not going to work because value should be a dict value struct. So how can we find out the type of value through macros? And the answer is we can use the generic operator, which was introduced in C11. And with the generic operator, we just give it a value, and then we can match the type it has and return something based upon its type. And this is all done because we can find the type of the value at compile time, which is a very useful feature. So what we can do here is, I'll call another macro which we're going to create called find type. We just pass in value for now. Now find type, I'm making it right here. This will just take in a value, let's just call it value, and it runs the generic operator. The syntax of the generic operator is first we're going to put in the value. I add it in brackets right here because sometimes the way the user formats the value, it can cause some issues. So it's best just to add some square brackets so the compiler just evaluates it or simplifies it down. Then we just pass in the type that we think is going to be and what we want to return if the value is that type at compile time. If it's a string, the user passes a string in, we're just going to return a dict value, and we're going to set the value to be a string. That's going to be equal to hashtag value. So we have to add some backslashes at the end of each line just to make sure it works. Whenever I have a backslash in a macro next to a parameter or an argument, what this does is it takes the value and then it wraps it around in it wraps it around in double quotation marks, which turns it into a string literal. So let's say I pass in the number 11, right? When I do value is currently 11, when I put the hashtag next to value, what that will do is just take 11 and then wrap it around in quotation marks. So now it's a string literal. And this is very useful because if we just try to pass value as it is, as a number, we'll get compile error because it expects a string literal if the union member is going to be a string. We can do the same thing for the other types. So if it's an integer, if it's a double, or if it's a float. If it's something else, so default is like a default statement in a switch case statement. It's just the branch which is going to be run if you can't find any other matching condition. So I'm just going to say it's going to be an integer. We'll just set that to 0 for now. Probably isn't ideal, we'll probably have some way to return an error, but right now it works fine. So what I'm going to do is just modify the code here to handle each type. Okay, so if it's an integer, just pass in an integer. We don't have to add the hashtag because it can handle it directly. It expects an integer, not a string. Double can just be the double. Float can be a float. Double val, float val. There we go. That looks good to me. Although my syntax highlighting is not working, which is a bit worrying, but hopefully when we compile it, we shouldn't get any issues. So now what we should be able to do is just remove these. Just remove the struct right here, and it should do it automatically for us. But we've got some errors. Let's see what's happening. So I think the problem is we got the extra comma at the end. Yeah, that's the issue. So we run the code, as you can see, we can just pass in the value directly here. Let's say we, instead of doing integers, we do floats to show that it can handle different types. So let's say now it's 10.10f. And then instead of doing integers, we print out the floats. This should be %f. Should be a float val, not float. And yeah, it works. We can also, if you want, there's a cool trick we can do. If we do 0.2f, that formats it so that it's only to 2 decimal places. So now it just shows 2 decimal places. If we do something like 3, does 3 decimal places, and 1 will just do something 1 decimal place. That's a pretty cool feature. We could also try strings as well, to show that we can just pass string literals and it will handle it for us. Just pass in some garbage, then we should hopefully get it to print out the right thing. So this will not work with strings, and we have to create our own function for strings like dictAdd, which is a bit annoying, but it's still quite useful since it can handle pretty much any other type. So like floats or doubles or integers, it can handle those fine. So it's a minor headache, but I think it's quite useful for what it does. So thank you for watching. I hope you enjoyed this video. If you guys have any idea of how we can solve this issue with passing strings into the dictAdd function directly and not having to create a separate function for it, because currently I can't think of any solution, since whenever we try to pass it in, these values get filled out with string literals and they don't expect string literals, they expect something else. So that's a bit annoying. if you guys have a way to solve that, I'd love to hear it in the comments. Also, if you enjoyed this video, you can check out another video, for example, a cool trick you can do with C, with macros. I'll leave that on the right side of the screen. And yeah, please like and subscribe. Thank you for watching. Bye.